Hi, this is Anders Pittman, and I just wanted to do a quick little screencast to kind of demo some of the stuff, the visualizations we've been working on for this DeNovoGear prototype visualization tool. So we're calling this thing mutmap, which is just short for mutation map. The idea being that you've kind of got this pedigree, and then we're overlaying or mapping the mutations that have been called by DeNovoGear on top of the pedigree. So I'm going to go ahead and refresh this, and you can see here this is the first visualization we worked on, and call it the Explorer view. And it's evolved quite a bit, but the basic idea was we wanted to be able to see for each locus what individual is being called as having a mutation there, and what's the type of mutation, and additional statistical information and for it. So you can see we've got the chromosome up here at the top, and you can go through and click on the different loci, and it'll take you to each one of these green bars is a mutation that's been called, and as you can see down here in the pedigree, that changes as we go through, and it also tells you like what type of mutation is being called. So in this case, AAA is gone to an AT. And there's also, you can see in this case, since the reference is not included, the color of the node is different. On the subject of color, there's an interesting one in here. Here we go. You can see that additional information is encoded in the color of the nodes, and they can actually have multiple colors. Now if I click on a node here, let's do this one, you can see there's some additional information on the right. Some of these values are defined in the VCF spec, and particularly I want to look at GT and GP. So GT is defined as, if it's 0/0, that means that you get both alleles, both bases are the reference. And if it's 0/1 like this, it's saying that it includes the reference and one copy of the alternate allele, as according to VCF. So if we look at a couple examples here, this node here is 0/0, so it's the reference in both cases for both bases, and then this one is 1/1, which means it's the alternative allele in both cases. And then this one is saying that it's 0/1. Now, this node is interesting in another way, because a better example of the 0/1 is this one here, because it's just completely orange. It's pretty much guaranteed to be 0/1, the reference and alternative. However, if you look at this, go back to this node, you can see that there's 3 different bars that are significantly sized. Although the orange is the largest, the green and blue still have about 25% probability. The blue represents that the reference is included. The blue represents that it's reference only, so it would be, if the reference is A, this would be AA. The orange means that the reference is included, so that could be AA, could be AC, AG, etc. And the green means that there's no reference at all. So GG, CC, TT, GC, etc. And you can see that that's borne out in the GP here, that shows the probabilities of the different types of breakdowns. And that is defined again in the VCF spec. So that just kind of gives you an idea of the different things here. Like I said, we've played with this quite a bit, but overall we don't feel like it's an incredibly effective visualization, primarily because it's hard to really explore. If you know what locus you want to look at, you can kind of go to it and then look and see what sorts of information you can get about it, look at the statistics, but it's not useful for really as a starting point. We think that this could be adapted to be more useful. One potential way to do that, if we come over here to the locations view, now there's nothing novel going on here, this is just a very stripped down genome browser, but you can kind of go through each chromosome and see the breakdowns per individual and get an idea of some patterns and things that might be useful. So you could imagine, maybe if you notice a pattern that a significant number of the individuals all seem to have a mutation in the same location, then you could go and say click on that and maybe it would then take you to the Explorer view and you could look at that locus. Or you could imagine other sort of interactions like that. But for now, this has limited usability, although we did use this as a way to develop, making this very responsive. So this view is nice because you can, as you resize it, everything automatically updates to be responsive in terms of, well, there we go, in terms of the layout and sizing of everything, which is pretty nice. Now, finally, this last view is kind of interesting. We call it the distribution view, and as I said before, we felt with the Explorer view, it's hard to kind of get a overall picture of what's going on, and we designed this view to be as a better starting point. So as you look at the pedigree, you can immediately see that these green bars represent the number of mutations called for each individual on the data set, and you can immediately see that this individual over here on the right has way more mutations than any others, and some of them have almost no mutations at all. So you can more quickly come up with questions to ask about, okay, well, what causes that? Is that individual have more phenotypic consequences from that as well? Maybe it's a data error. I think that would bear more looking into. Another interesting thing about this view is underneath the nodes, you can see we have these bars, and these are meant to represent the breakdown of the types of mutations that are occurring for that individual. So, for an example, this one on the right, it has 1,858 mutations. This bar is the breakdown of those 1,800 mutations in terms of, are you seeing a lot of A's going to C's? Are you seeing a lot of T's going to G's? What types of base changes are you seeing? And I won't get into the details of what the specific color coding is, but that's basically what it's telling you. And I experimented a little bit with the how to show this. This is the one I settled on that I think makes the best trade-offs, but there's kind of two other extreme takes on it. One is you can go with the bar charts, which I think this shows the information the clearest way. It's the best use of visual variables because you're just encoding length, and you can very easily compare the different types of mutations for each individual. However, it's kind of bulky. It takes up more space. Might not be ideal on small screens, for example. Going kind of the other direction, this is the most compact, where we kind of encode the information directly into the node. However, I feel like this is not the right trade-offs to make because, first of all, you're using two different types of charts for the males and the females. And you've got the pie charts for the females, you have stacked bar charts for the males, which is not ideal. I mean, even pie charts in general, everybody loves to hate them. It's not the most effective way to encode information for a human brain. The males aren't as bad, but they're still kind of strange being square-shaped. It's not as easy to compare. So overall, I think that the stacked bar underneath is a good trade-off. It's consistent between males and females. It's a pretty good trade-off in terms of the visual variables being encoded. You're still using length, even though you lose like the nice layout of a bar stack of the bar charts. I think that it's nice. However, I think that long-term, being able to switch between these two is still useful. Maybe this could be used on smaller screens, whereas if you have more space, this gives you a little bit of a different view on it. So that's kind of a quick overview, just some of the features we have. Obviously, this is still very early prototype. We need keys in here for the colors. We need tooltips and things to help explain how to use this. And we just kind of got to narrow down on what views are more valuable. So we're at the stage right now where we're kind of ready to start getting more user feedback and figuring out what tools, what views are useful and for getting like actual work done. So thanks for your time. That was just kind of a quick demo, and hope you enjoyed it.